Today we are going to be talking about angle relationships when two parallel lines are cut by a transversal. So a transversal, I'm actually going to color the transversal right here in pink. So just tracing over it in pink. A transversal is a line that cuts two or more lines at different points. Now the transversal in this case, PQ, and the lines AB and CD form 8 different angles. Now, we can classify these angles and make relationships about them using some different vocabulary that we see here. We're going to go through this vocabulary and identify which angles meet each definition so that we can, first of all, help figure out how big each angle is based on an angle that we've been given, and so that we can continue to make these relationships through our notes. Corresponding angles lie on the same side of the transversal, PQ, on the same side of lines AB and CD. Whenever I think of corresponding angles, I think of what if I just took this line and put it right on top of that line? Which angles would match up from the top section to the bottom section? So in this case, the corresponding angles that we have, angle 1 corresponds to angle 5. Angle 2 corresponds to angle 6. And this little sign right here, it just means angle. Angle 3 and angle 7 match up because they're both below. And then angle 4 and angle 8 match up. And those are corresponding angles. You do need to memorize this vocabulary. It is extremely important for you to use. Then we have alternate interior angles. Alternate interior angles are interior angles that lie on opposite sides of the transversal PQ between lines AB and CD. So, these are interior angles. Angle 3 and angle 5 are alternate interior angles. Then angle 4 and angle 6 are alternate interior angles. Then alternate exterior angles lie on opposite sides of the transversal PQ and outside of the lines AB and CD. So these are going to be our ones outside of those middle places. I always think of these as being like outside of the sandwich and on opposite sides of the transversal. So in this case, angle 1 and angle 7 are alternate exterior angles. And angle 2 and angle 8 are opposite exterior angles. Finally, we have same side interior angles, or what you may also be seen as consecutive interior angles on the same side of the transversal between the lines. So angle 3 and angle 6 are same side interior, aka consecutive angles, and angle 4 and angle 5 are same side interior angles. And I'm just going to go ahead and highlight all of those important vocabulary words. So alternate interior angles, alternate exterior angles, same side interior angles, or you can see it as consecutive interior angles. All of this is just helping us understand the relationships that we can make between different angles that have been cut by a transversal. We're going to understand what these relationships mean in just a second. Now, we're going to come down to some of these figures, and we're going to identify what type of angles some of these are. All right. And I don't really care quite as much about figure 1. I want us to focus on figure number 2 as we identify these, because that's going to be a lot of what we see here. So if we can just focus on figure number 2 for this, we're really not going to worry as much about figure 1. So here are corresponding angles. First of all, corresponding angles are what comes from the top part and matches up with the bottom part. Angle 1 and angle 5. Angle 2 and angle 6. Angle 3 and angle 7. Angle 4 and angle 8. Bless me. Alternate interior angles. 3 is inside and it's opposite from 6. 4 is inside and it's opposite from angle 5. Alternate exterior angles means it's outside of those lines. Angle 1 matches with angle 8. Angle 2 matches with angle 7. And then finally, same side interior angles. These are inside the two parallel lines. 3 and 5 go together. And 4 and 6 go together. All of these relationships do have a meaning and will help us figure out what some of our angle values as we start to move on to our next page. So we are going to go ahead and look at our next page of notes now that we can identify what are corresponding angles, alternate interior angles, alternate exterior angles, and same side interior angles. As we look here, we have a whole nother chart here that tell us about these relationships and what they mean for each of the angles. Now, these only exist if the two lines are parallel. Otherwise, it doesn't really work. So, corresponding angle postulate. So this is just a fancy word that says, if this is this, then that's that. It's sort of kind of like a theorem. It just has a little bit of different meaning. If two parallel lines are cut by a transversal, then the pairs of corresponding angles are congruent. So whatever angle from the top matches up with the bottom, those two angles are going to be congruent. Now, I like to put congruence marks. So angle 2 is going to be congruent to angle 5, which is what we've been told here. Sometimes you're going to see those congruence marks, and those will play a little bit bigger of a role as we move in through all of this. Now, if angle 2 is congruent to angle 5, then angle 1 must be congruent to angle 6. So 1 is congruent to 6. And sometimes you will see that written with the angle marks. Sometimes you will see it not written with the angle marks. I tend to write it with the angle marks, but that's just me. Angle 3 is going to be congruent to angle 6. So congruent to angle 8, sorry. So angle 3 is congruent to angle 8. And then angle 4 is going to be congruent to angle 7. Now, alternating interior angle theorem. This tells us that if two parallel lines are cut by a transversal, then the alternating interior angles are congruent. An example that we have here is 3 is congruent to 6. Now this says to name 3 more, but there's only one more set of interior angles. So angle 4 is going to be congruent to angle 5. Angle 4 congruent to angle 5. And I'm just writing these both ways, both sets of notation. Now we have the alternating exterior angle theorem. So this says if two parallel lines are cut by a transversal, then the alternating exterior angles are congruent. Our example that we're given here is angle 2 is congruent to, and this should be 7. I don't know why it says 6. We're going to mark that out. Two is congruent to 7. So angle 2 and angle 7 are congruent, and that means angle 1 and angle 8 are congruent. So 1 is congruent to 8, or we could see that written with the angle notation. Now, these last two are where we get a little trickier. Everything else we've seen, it's this angle equals this angle. With same side interior angles, it tells us that if two parallel lines are cut by a transversal, then the same side interior angles are supplementary. Supplementary means adds up to 180 degrees. So our example here is angle 3 plus angle 5 equals 180 degrees. The other two interior angles that we have are angle 4 and angle 6 equals 180 degrees. And remember, you could see that written with those angles out front in our notation. And then finally, we can also talk about same side exterior angles. This wasn't something we discussed on the first page, but it does apply as well. Same side exterior angles say that if two parallel lines are cut by a transversal, then the same side exterior angles are supplementary. So that means that 2 and 8 equal 180, as well as 1 plus 7 equals 180. One thing that I like to do whenever I'm working with transversals is I like to take these transversals and throw congruence marks on them. So this is just something I'm going to do at the bottom of my page. It's not anything that's been thrown onto your notes or anything like that. But when you have a set of parallel lines that have been cut by a transversal, we know that our corresponding angles are congruent, but also we know that, let's see, these angles are congruent, and then these angles have a different level of congruence. Anytime you're dealing with a parallel line cut by a transversal, opposite angles are congruent, and any angles that are beside one another add up to 180 since they're laying on a straight line. If you have one congruence mark here and one congruence mark there, it means those angles are equal. If you have one congruence mark here and two congruence marks there, it means that they add up to 180 degrees. This will match up with all of the rules that you can see here. Now that we've introduced all these rules, we're going to move on to our next page, and we're going to be identifying how these angles are related, as well as stating how much they are worth, or how big those angles are. So we're going to move on to our next page. This top section here is all about identifying these special angle pairs. So we're going to assume that these two lines are parallel. It says angle 3 and angle 13. If we assume that these lines are parallel, even though they don't look parallel, angle 3 and angle 13, both of these are technically in between two parallel lines that have been cut by a transversal. Sometimes it helps to look at it this way, and we can see that those are interior angles. So angle 13 and angle 3 are same side interior angles because they're both on the same side of the transversal in between two parallel lines. Angle 8 and angle 10. Angle 8 is right here. Angle 10 is over here. If we slide our page to the side, 8 and 10 are both outside of the parallel lines, and they're opposite from each other. So these are alternate exterior angles. For angles 11 and 15, we can look at our transversal straight on here. As I look at this top half and match it to the bottom half, 15 and 11 are in the exact same place. So these are corresponding angles. For number 8 and number 6, eight and 6 are both on the same part of the transversal, and we actually don't have a special angle name for these because there's no relationship within a triangle like that. The only thing that we could say about these angles are that they are vertical angles, which is something that we have not mentioned. So a vertical angle is where if you were to draw a line from one angle to another, those angles are congruent. 8 and 6, these are congruent. And a vertical angle is where it shares the same point and they're opposite from each other. So you could draw a line from one to the other here. These are vertical angles. We didn't really talk about that in our notes so far. Angle 1 and angle 6, they're both inside two sets of parallel lines. Angle 1 is on this side of the transversal, angle 6 is on that side. So these are alternate interior angles. Angle 6 and angle 10. If I were to turn my paper sideways, angle 6 matches up with what we see down here. So angle 6 and angle 10 are corresponding angles. It's really tough when we have so many sets of parallel lines and we need to turn our paper different ways to see our shape different ways. And then finally we have angle 14 and 15. These two are beside each other. These are what we could call consecutive angles in some cases, But since one is exterior and one is interior, we don't really want to use that. So the best way to describe these two is 14 and 15 lay along a straight line. Because they're on a straight line, we would want to call these supplementary angles because these are going to add up to 180 degrees since they lie along the same line. This is one of the most challenging instances of transversals that you're going to see. Most of the rest of what we do is going to be a lot more simplified than what we saw here, or we're only looking at one specific piece at a time. As we move on to the next section, we're going to start to do some math with these. This is going to involve us understanding which angles are congruent and which angles are not. So in this case, I like to use my congruence marks that I showed you guys on our last page. This angle is congruent to this angle. This angle is congruent to that angle. My congruence marks match up with the top compared to the bottom. Then every other angle gets 2 congruence marks to represent that they are congruent to each other, but not congruent to the first 4 angles we paid attention to. This tells us that angle 1 and angle 2 are what we're working with. It tells us what angle 1 is, and it tells us what angle 2 is. Now, looking at my congruence marks here, I can tell that those angles are congruent. But if we want to understand the reason why, angle 1 and angle 2 are on opposite sides of the transversal, and they are outside of the set of parallel lines. So these are alternate exterior angles. And what we learned about these is that they add up to 180 degrees. Oh wait, no, that's the same side, exterior angles. Alternating exterior angles are congruent. My bad. So we could say that angle 1, aka 3x minus 17, equals x plus 1. Once we know that these two angles are equal, which we can see by the same number of congruence marks, we're going to solve our angle to get x. I'm going to start by getting my x's all on the same side and subtracting x from each side. That leaves me with 2x minus 17 equals 1. From there, I'm going to add 17 to each side, which gives me 2x equals 18. I divide each side by 2, so x equals 9. As I move on to the second part here, it's having me talk about angle 3 and angle 4. As I noticed from these congruence marks that I drew, angle 3 has 1 congruence mark, while angle 4 has 2 congruence marks. Both of these are in between the parallel lines, meaning that they're interior angles, and they are on the same side of the transversal. So these are same side interior angles. Since these are same side interior angles, that means that angle 3 and angle 4, when added together, will equal 180 degrees. So to solve this problem, I'm going to take angle 3, which is 20k plus 11, and add angle 4, which is 8k plus 1. Then set it equal to 180 degrees. And that's because angle 3 plus angle 4 equals 180. From there, I'm going to combine my like terms since everything's on the same side of the equals mark. So 20k plus 8k leaves me with 28k. 11 plus 1 is 12, equals 180. I'm going to subtract 12 from each side. So 28K equals 168. And then I'm going to divide each side by 28. So 168 divided by 28 is 6. So K equals 6 here. As we move on to our next one, I'm going to start by following the same protocols. So I'm going to start by drawing my congruence marks throughout my transversal. This is the number one way for me to remember which angles are equal and which angles add up to 180 degrees, because those are our two options. They're either equal or they add up to 180. This is just a way that makes it easier for me to see the relationships firsthand, and then I can dig into the reasons why. My first problem is asking me about angle 1 and angle 2. Here, I see angle 1 has 2 congruence marks, and angle 2 only has 1 congruence mark. We don't have a specific relationship for angles that are both exterior and interior here, other than saying that these are supplementary angles. And the reason we say that is because they lie along the same line. Now, supplementary angles add up to 180. So I'm going to take angle 1 and angle 2 and add them together, then set equal to 180. 95 plus 7h plus 55 minus h equals 180. From there, I'm going to combine my like terms on this side of the equals mark. 95 plus 55 is 150, plus 7h minus h is 6h. And that all equals 180. I'm going to subtract 150 from each side, which leaves me with 6h equals 30. And I divide each side by 6 to give me h equals 5. As I move on to number 11, we have angle 3 and angle 4. Both of these angles are outside of the parallel lines, and they're on opposite sides of the transversal. So these are alternate exterior angles, which means that they are congruent. Since these two have the same sign, they only have one congruence mark, I can set them equal to each other in order to solve for my variable. 5k plus 12 equals 7k minus 16. I'm going to start by getting all of my k's on the same side of the equals mark. So I subtract 5k from each side. The reason I can't combine my variables like I did in the second step, or like I did in the first problem here, was because we have an equals mark in between them. Anytime you cross the equals mark, you have to do the opposite operation. Once I subtract 5k from each side, I'm left with 12 equals 2k minus 16. I'm going to add 16 to each side, which leaves me with 28 equals 2k. From there, I divide each side by 2, which leaves me with k equals 14. We're going to move on to our last page of notes to go over just a couple more of these problems. As we look at number 12 here, one thing I'd like to point out is that we have 3 angles here, but each of these 3 angles have different variables. This is going to impact how we solve this problem. To start off with, I'm going to go ahead and go through and put my congruence marks on my transversal, just because this visually helps me see what angles are congruent and which ones may not be. As we see here, angle 1, angle 2, and angle 3 all have the same congruence marks. That means that all of these angles are going to be equal to each other. Angle 1 and angle 2 are vertical angles, so I'm just going to make a note of that at the top. So angle 1 and angle 2 are vertical angles, which means that they are congruent. And then angle 3 and angle 1. Let's see, I'm trying to figure out the best way to write it. Angle 1 and angle 3 are alternate exterior angles. And I forgot to mention that angle 2 and angle 3 are corresponding angles. So all of these mean that they are congruent. In order for us to solve, we actually want to wait to use angle 1. Angle 2 and angle 3 both use the variable x. Since they use the same variable, it's going to be easiest for us to solve there. We don't want to solve for two different variables at the same time because that's pretty impossible. We have 2x equals 4x minus 30 because all of these angles are congruent. To solve, I need to get all of my x's on the same side. I'm going to do this by subtracting 4x from each side, which leaves me with negative 2x equals negative 30, just because I didn't want to be left with nothing on that side. From there, I'm going to divide each side by negative 2, which tells me that x equals 15. Now, in order for me to solve for y, I'm actually going to take what I found for x and plug it in to one of my angles. So for example here, angle 2 was 2x. 2 times 15 means that angle 2 is just equal to 30 degrees. Since all of these angles are the same, that means that each one of these angles must equal 30 degrees. So to solve and find out what y is, I can do 7y plus 16 equals 30. Because all of these angles are equal, and we can see here that angle 2 is equal to 30 degrees because we plugged in x. I'm going to subtract 16 from each side, so 7y equals 14, and divide each side by 7, which tells us that y equals 2. This is one of the more complicated ones since we had to solve for two different variables, but thankfully everything was congruent. Finally, we have one more section down here at the bottom, and this is just to help reinforce all that we've worked on and helping us understand where these congruence marks come into play, etc. So here, this tells us that angle 1 is 115 degrees, and angle 12 is 110 degrees. We are going to use this information to help us find all of these different angle measures. To do that, I'm going to draw my congruence marks. I always start in the top right corner with one mark and then go on opposite sides from there. The same marks will apply to this line since we have our corresponding angles. Everything else that doesn't have a congruence mark right now will get 2 congruence marks. This helps me clearly see the relationships between each of the angles and make sure that I know what is congruent, or what is not congruent. Remember, if they don't have the same number of congruence marks, so if we have one congruence mark and then two congruence marks, it adds up to 180 degrees. We know that angle 1 is 115 degrees. So if it has one congruence mark, that means that it is 115 degrees. We also know that angle 12 right here is 110 degrees. So we're going to use that information to help us. These two are sort of kind of split, and I'm actually going to switch this up a little bit. I'm going to put colors on this set. So I'm going to make that set blue, since 12 is 110. And that's going to help me see the difference between those two. So we worry about this one with this amount, this one with this amount. All right, if we want to find angle 9 is right here. Angle 9 and angle 1 correspond to each other. These are corresponding angles, so I'm just going to put corresponding. And since corresponding angles are congruent, that means that angle 9 is 115 degrees. Next, we have angle 10. Angle 10 has two congruence marks, while angle 1 has one congruence mark. We know that one congruence mark plus two congruence marks equals 180. Since I don't know what angle 10 is yet, I'm going to identify that as x. And also, these two angles, they do not have a relationship with each other that we've really talked about, so we don't have to write anything there. So since angle 1 and angle 10 have different congruence marks, I can say x plus 115 equals 180. I subtract 115 degrees from each side, and I'm left with 65 degrees. Another way that you could think about this is angle 9 and angle 10 are supplementary. And I can just put that there. Now we're going to talk about angle 8. Angle 8 is over here in my blue. We know that angle 12 is 110 degrees, and that has two congruence marks. Angle 8 only has one congruence mark. Both of these are inside and are on the same side of the transversal. So these are same side interior. Since these two are supplementary instead of congruent, since they both have different congruence marks, I would do x, which represents angle 8, plus 110 equals 180. Subtract 110 degrees from each side, and we're left with x equals 70. Angle 3 is actually congruent to angle 8. So angle 3 and angle 8 are what we call vertical angles. So since these two are vertical angles and are congruent, that means that angle 3 must also be 70 degrees. Angle 4 here, angle 4 and angle 12 are corresponding angles. They match up with each other. So since they are corresponding angles, angle 4 and angle 12 are congruent. So angle 4 must be 110 degrees. Angle 11 has one congruence mark, and angle 11 corresponds to angle 3, which we've already found. So angle 3 and angle 11 are corresponding. That means that angle 3 and angle 11 must both be the same at 70 degrees. As we come back to our pink side, angle 5 has two congruence marks. Angle 5 and angle 10, since we already know angle 10, are alternate interior angles, since they're both inside the parallel lines. So angle 5 and angle 10 are alternate interior angles. Alternate interior angles are congruent, so angle 5 must also be 65 degrees. And then finally, angle 14 is an alternate exterior angle with angle 1. So since these are alternate exterior angles, that means that that must be 115 degrees as well. This was a lot going on because we had two different transversals. It wasn't like before where we assumed all lines were parallel. That's why I changed that to a blue situation. And we are going to mark out this entire section down here at the bottom because we went through and identified a lot of our angle pairs right there. This is a lot of vocabulary and can sort of kind of be overwhelming. We're going to spend a lot of time practicing this today. If you tend to struggle with vocabulary, I strongly encourage you to use the congruence marks method like I did here. Because if you can identify if they have the same congruence marks or different congruence marks, it's easiest to be able to solve and do the math whether you understand the vocabulary or not. Please let me know if you have any questions about this as we'll be working on this over the next day.